Microsoft just rolled out a new AI model called Orca AI, and from the looks of things, this language model absolutely destroys other popular AI models, including ChatGPT. I know that sounds audacious, but you will agree by the time you get to the end of this video. As it says in the Orca AI research paper released by Microsoft on the 20th of June 2023, Orca is an AI model that learns from the thought process of GPT-4. This small, robust model borrows the vast database and computational resources of GPT-4 to solve more specific problems. In other words, it takes the edge off by easing up memory and computing requirements, making it more efficient and better for scaling. Orca AI also trades up size for depth. By leaving the heavy lifting to the parent AI model, Orca AI focuses its own reasoning power on deepening its understanding of the subject and offering more comprehensive answers. To answer your questions, here's how Orca AI piggybacks on larger AI models. Firstly, Orca sends queries to the larger model. The larger model uses its vast database of approximately 1 trillion parameters to solve it. Orca asks the larger model for a detailed explanation of how the problem was solved under the hood. It notes the reasoning behind the parent model's solutions and repeats the same thought process for subsequent questions. Now, what makes Orca AI special is the last bit, its ability to see how the large model went about solving the problem and copy its thinking methods. In the AI world, this process is called explanation tuning. Other smaller AI models like Vicuna, which came before Orca AI, take a much different approach to solving problems. While they rely on the thinking capacity of a larger model, they imitate the way it answers the questions and do not bother about the how. This method is called instruction tuning. So while older models are copying or lifting answers from the parent model, Orca AI actually learns how the larger model solved the problem. By looking at the chain of thought behind the larger models, it develops a mind of its own and gives more comprehensive answers. Isn't that a classic example of the apprentice becoming the master? Later in the video, we're going to talk about how exactly Microsoft's Orca AI picks the brain of larger models, so hold tight to your seats. Before we go into the working principles of Microsoft Orca, let's get ourselves acquainted with the language model it's based on first, GPT-4. By now, I'm sure we're all familiar with ChatGPT, a chatbot that seems to have all of the answers. You may have asked ChatGPT to do one of these things in the past: answer questions, summarize text, do translations, creative writing, write or debug code. Two major components make these tasks possible: pre-training data for preparing the AI to recognize speech patterns. GPT-4 is fed with text from articles, web pages, and documents to help it learn how to put words together. A deep learning model which works on the training data is called a transformer. It enables the computer to form associations and understand the correlation between words and phrases so it can imitate human interaction. ChatGPT is simply a user interface that allows you to interact with the brain's GPT-4 over a text prompt. For the techies in the house, we're about to get to the sweet stuff, the technical breakdown of how Orca AI actually learns from its teacher, the GPT-4. While on the topic, it is important for you to know that Orca AI isn't the first light AI model created to piggyback off bigger ones. In the past, developers have tried to cut computational cost and ramp up efficiency with smaller language models that mimic a bigger model. Sadly, these smaller models didn't do too well. They work fine for simple queries, but tend to fumble vague or more complex questions. Microsoft finally got it right with Orca AI. This model doesn't just want answers, it wants to know how the larger model arrived at them. The goal of the Orca is to mirror GPT-4's reasoning process. GPT-4 doesn't magically whisk out the responses to user requests. It works out the answers in its internal state by performing logic functions on the information at its disposal. Interestingly, you can make GPT-4 explain itself whether it's in the mood to or not. You just have to ask the right questions. With every query, the Orca picks the brain of the GPT-4, digging up everything it can to ensure that it gives the user a contextually appropriate response. These detailed explanations are essential for humans and other small models to learn how to solve problems themselves given the same data resources as the AI. which in this case is mostly the internet. And that's how Orca does it. It accesses these explanations by asking ChatGPT prompt-specific questions. ChatGPT plays the role of the teaching assistant, entertaining questions and giving valuable insight on how it can grow its cognitive abilities. Commands like "explain it to me like I was 5" or "give me a step-by-step thought process" give Orca AI access to GPT's train of thoughts, allowing it to progressively learn how to solve problems using similar steps. These kind of prompts are called explanation prompts. By combining these explanation prompts with standard prompts like "when did the Cold War end?" or "who invented aeroplanes?", Orca gets both these simple answers and some detailed explanations behind the answers. Note that Orca doesn't just throw random questions at GPT-4, it has a query system in a wide range of subjects, so it knows how to respond to whatever question the user asks. To this end, Orca leverages FLAN 2022, a library of 1,000 tasks and 10,000 instructions to probe GPT-4 for explanation traces. To train for more complex tasks, Orca spins the queries from FLAN 2022 by combining multiple tasks together. Training Orca with this huge collection of tasks with varying complexity helps Orca achieve human-like intelligence. The size of Orca's tuning data is another feature that sets it aside from other competing models. While other popular models tune their algorithm with data sizes ranging in the thousands, Orca works with a data size of 5 million. After learning to solve problems from the explanation traces, Orca tries to replicate the same thought process while performing new tasks. Orca generates its own explanations and compares them with that of larger models. That way, it continuously trains itself to mirror the parent model's problem-solving technique over time. Note that Orca's learning curve is not limited to GPT-4 alone. It can access the database and analytical reasoning of any large foundation model out there. Orca maintains the quality of its responses by carefully selecting imitation data as it samples through a plethora of LFMs. Seeing how much work goes into the problem solving with Microsoft's small AI model, it is easy to understand why other instruction-tuned models like Vicuna 13B don't come close. Vicuna is an older, light AI model that tackles problems using instruction tuning. As we said before, instruction tuning is a technical way of saying it is trained by the questions and answers provided by a large-scale language model. Orca outperforms other models because it is a more sophisticated technique called explanation tuning to solve problems. Unlike instruction tuning, where the learning model just observes the larger model's question-answer pairs, in explanation tuning, the model absorbs the entire thinking process. Thanks to explanation tuning, Orca is smarter, more flexible, and can handle a wider range of complex tasks when compared to other small AI models. It also has a more advanced natural language processing, allowing it to understand vague questions and give suitable answers with the right context. A handful of benchmark tests prove that Orca's generative and comprehensive abilities outperform other small or large-sized AI models. Tested alongside models like Vicuna 13B, Text DaVinci 003, ChatGPT 3, and GPT-4, and guess what? It crushed all AI systems in terms of the following qualities: text summarization, text generation, image captioning, and other functions. This table summarizes Orca's performance alongside other popular AI models. Big Bench Hard, an academic benchmark, tested the performance of Orca on professional and academic exams. According to BBH's evaluation, Orca is twice more accurate than its instructional tuned rival, Vicuna 13B, and surpasses ChatGPT, GPT-3. In short, Orca AI is your best bet if you're preparing for SATs or other professional exams. Test results from Superglue indicate that Orca is better than other competing AI software and almost on par with GPT-4, behind by just 4%. CNN and the Daily Mail agrees with Superglue's results, putting Orca ahead of other models and second to only GPT-4. Coco Captions rates Orca on top of other AI models, with GPT-4 following closely with just 1 point less. Despite being a small model, Orca's high benchmark rating from several critics proves that sometimes less is more. Bigger does not always mean better. Orca is optimized to save resources by depending on larger foundational models such as GPT-4 to do the rigorous computing. This makes Orca AI accessible to researchers and academics who need AI for specific use cases. Instead of running huge data centers, they can run Orca efficiently from a single GPU. In a nutshell, Orca AI is a cost-effective solution for light users. Orca was developed as an extension of Vicuna and has 13 billion parameters. In collaboration with the GPT-4 language model, which is said to have more than 1 trillion parameters, Orca AI is a small but powerful tool that is good for everyday problem solving and comprehensive search. The small AI model can give an impressive performance when tested on professional and academic exams such as the SATs, GRE, LSAT, and GMAT. Another plus with Orca is the fact that it's open sourced. This means developers can contribute to the code and add or improve the AI features. To top it off, Orca supersedes other popular AI models in complex zero-shot reasoning by 100% according to benchmark tests. This means that it is the best at solving new problems without training data to support. An example of a problem that requires zero-shot reasoning is asking Orca AI to describe how a zebra looks when it has never been fed images of an animal. Microsoft's breakthrough with Orca shows the AI community that training AI models with step-by-step explanations, whether offered by sophisticated foundation models or humans, is the next step forward for the rapid development of AI language models. If you like this content, don't forget to like and subscribe, hit the notification bell, and we'll see you in the next video.